The story of Venus, a knife hidden among feathers. It's time to turn our gaze towards another fascinating neighbor of Earth, Venus, the planet that has ignited human imagination for millennia. Known as the morning star or the evening star, Venus is a world of contradictions, a place that almost seems like Earth's twin, but hides a hellish face beneath its brilliant surface. In this new chapter of our series, we won't just describe its well-known features, we'll go beyond, exploring its geological history, toxic atmosphere, extreme conditions, and the latest scientific discoveries that continue to astonish astronomers worldwide. Exhaustive truly means that a detailed narrative, rich with information and insights, that will make you see Venus with new eyes, appreciating its complexity and allure. Despite often being overshadowed by the popularity of Mars or the gas giants like Jupiter and Saturn, Venus is a planet that, especially in this historical phase, deserves our full attention. It's a natural laboratory for studying runaway greenhouse effects, a warning to understand the delicate balances that govern planets, and perhaps one day it might even reveal clues about the possibility of life in extreme conditions. With this video, we will guide you through the acidic clouds, active volcanoes, and rocky plains of Venus, unveiling a world that, despite its apparent hostility, continues to inspire scientists, writers, and dreamers. So, get ready for an experience that will take you far away, but not too far, because Venus is always there, shining in our sky, reminding us that the universe is full of stories yet to be told. Enjoy the journey. Alright folks, you decide whether Venus deserves to be called Earth's twin sister or not. I don't hear any dissenting voices, and indeed with an average diameter of 12,103 kilometers, about 7,520 miles, roughly 95% that of Earth, and a mass that's 81.5% of Earth's, who could deny that in terms of size and physical characteristics, Venus and Earth look like two planets separated at birth? These similarities also extend to their density, 5.2 grams per cubic centimeter for Venus compared to Earth's 5.5 grams per cubic centimeter, and surface gravity. On Venus, you'd weigh about 90% of what you do on Earth. You'd feel just a bit lighter. But it's not just about size. The two planets also formed in the same region of the solar system, which means they have very similar chemical compositions, with one little difference. While Earth turned into a green and blue paradise, Venus turned into a toxic inferno, an incredibly hot, dry world that's absolutely hostile to any form of life, to the point where one of the current goals of planetary scientists is to understand how our twin transformed this way. It's not just scientific curiosity. Understanding this could teach us something about the climate changes happening here on Earth too. But let's take it step by step. Venus is, after the Moon and the Sun, the brightest object in the sky, and its brilliant presence in the warm hues of twilight has always sparked curiosity and admiration. The planet is called Hesperus when it's the evening star and appears after sunset, and Lucifer when it's the morning star and precedes the sun at dawn. This happens because, like Mercury, Venus is one of the inner planets of the solar system, meaning its orbit around the sun is closer than Earth's. And due to orbital geometry, this means we'll never see Venus more than 47 degrees away from the sun, maximum elongation. For Mercury, the same thing happens. Its maximum elongation doesn't exceed 28 degrees. Its brightness surpasses Sirius by 20 times and Jupiter by 6 times. And at its brightest, it can't even cast a noticeable shadow on Earth. Even in broad daylight with a clear sky, it's possible to spot it with the naked eye. Its particular brightness is due not so much to its size, similar to Earth's, but rather its frequent proximity to our planet and the reflective nature of its cloud cover. And because of those impenetrable clouds, until half a century ago, astronomers had to make do with calculating that Venus orbits the Sun in 224.7 days, at an average distance of 108 million kilometers or 67 million miles, about 0.72 times the Earth-Sun distance. And that its orbit is the least eccentric of any planet, deviating from a perfect circle by only about 1 part in 150. For Earth, just to understand, this value is 1 to 60, while for the most eccentric orbit, Mercury's, the value is 1 to 5. And while Venus and Earth dance around the Sun, the distance between them varies from a minimum of 42 million kilometers or 26 million miles to a maximum of 257 million kilometers or 160 million miles. Similar to the Moon, the portion of Venus's surface visible from Earth is not always fully illuminated, and the variation in illumination during its orbit creates phases. As these phases change, so do the apparent diameter and brightness perceived by an observer on Earth. The full phase, during which the side of the planet facing Earth is fully illuminated, occurs when Venus is in superior conjunction with the Sun and is not visible from our planet. At inferior conjunction, Venus's apparent diameter reaches its maximum value of 66 arcseconds, and it's in its new phase, with the side facing Earth almost completely in shadow. But of course, Venus's phases aren't an intrinsic aspect of the planet, but a consequence of its orbit and its position relative to us and the Sun. So what's its real nature? Because of the thick, continuous clouds, nothing was known about it before the 20th century. For example, did the planet rotate? And at what speed? Well, it's hard to believe now, but Venus's rotation period was measured using the Goldstone radio telescope in California only in 1961, and its retrograde motion was definitively confirmed only in 1964. Yes, you heard that right. Until the 1960s, when the era of radar measurements began, we didn't even know the rotation period of our closest planet, nor the tilt of its axis. And the radar measurements delivered astonishing data, revealing that Venus's rotation is truly unusual. The planet rotates around its axis very slowly, completing one rotation approximately every 243 Earth days. It's the only planet in the solar system that takes longer to rotate around its axis than to orbit the Sun. These two motions combine in such a way that one day on Venus, the time it takes for the Sun to appear directly overhead, set, and then rise again directly overhead lasts about 117 Earth days. Because of its slow rotation, Venus has retained an almost spherical shape compared to Earth and most other planets. The rotational force of a planet generally causes a bulge at the equator and flattening at the poles. These distortions are minimized on Venus. Then there's the fact that Venus rotates in a retrograde motion, meaning in the opposite direction to most other planets in the solar system. 6 of the 8 planets rotate counterclockwise as viewed from above the North Pole, while only Venus and Uranus rotate clockwise. For an observer on Venus, the Sun would appear to rise in the west and set in the east, if you could see through the thick clouds. Venus's axis of rotation is tilted by only about 3 degrees relative to its orbital plane. This means the seasonal variations on the planet are likely very mild. Unlike Earth and most other planets, Venus does not have a global magnetic field, and this might also stem from its extremely slow rotation. Scientists think that a planet's rotation helps drive fluid movements in its core that generate a magnetic field. And there's more. Although there's no unanimous agreement on this, Venus's rotation seems to be somehow synchronized with Earth's position along its orbit. So much so that when the two planets get close, Venus always shows us the same face. A phenomenon surely due to a still unresolved combination of gravitational interactions. But let's move on, or rather, let's stay a bit longer in the 1950s, when astronomers could only speculate about what Venus might be hiding under its blanket of clouds, and dream of a warm, humid world like our rainforests, the only planet besides Earth likely capable of hosting even evolved forms of life. A romantic dream destined to clash very soon with a harsh reality. Under the absolute white of its clouds, Venus hid a dark secret, a horrendous face, and an infernal environment where it's difficult, if not impossible, to imagine any form of life. As it would soon become known, Venus's surface is covered with black, scaly, sterile volcanic rocks, crisscrossed by solidified lava rivers expelled from hundreds of volcanoes. The atmosphere is very dense. The surface atmospheric pressure is 90 times that of Earth, similar to being 1,000 meters or about 3,280 feet underwater. That's roughly the maximum depth at which our submarines operate, though research bathyscapes and rescue vehicles can go much deeper. The atmosphere is mostly composed of carbon dioxide with nitrogen and traces of sulfuric acid, hydrogen chloride, and hydrogen fluoride. These substances precipitate on the surface as acid rain, quickly destroying machinery like spacecraft landing on the surface. The clouds aren't made of water droplets like on Earth, but sulfuric acid droplets. The sun's rays weakly filter through the dense, sulfurous atmosphere, casting an ugly, yellowish tint on the surface. Before the space age, few of these details were known. Only the general composition of the atmosphere, its high density, and its temperature, which is undoubtedly the least favorable aspect for life on the planet. In 1956, Cornell H. Mayer, a pioneer in radio astronomy, and his colleagues at the United States Naval Research Laboratory observed Venus in the microwave frequency. They discovered that its surface had a much higher temperature than Earth's, so hot it could melt lead. The first spacecraft to visit Venus was Mariner 2, an American probe that performed a flyby in 1962. The initial plan was to launch the probe with a new rocket, which had some development issues. So they had to settle for an earlier, smaller rocket with a lower payload capacity. Consequently, the instrumentation on Mariner 2 was significantly reduced from the original plan. Nevertheless, the mission was successful. The radio astronomical studies from 6 years earlier had probed Venus's atmosphere from afar, but couldn't provide a definitive answer. The most important scientific result of Mariner 2 was confirming up close that Venus's surface temperature is very high, over 400 degrees Celsius or 752 degrees Fahrenheit. In the 1960s and 1970s, other Mariner probes were launched, but we owe our detailed knowledge of Venus's surface mainly to a series of Soviet landers that parachuted below the clouds. In the 1960s, NASA focused on the Apollo program, which would put the first man on the moon, in line with the challenge issued by President Kennedy in a famous 1962 speech. We chose to go to the moon. Meanwhile, the Soviet Union dedicated most of its space missions to the closest planets, Venus and Mars. The scientific exploration of Venus began in 1967 with the Venera spacecraft series, initially designed by aerospace engineering pioneer Sergei Korolev. Like Mariner 2, the first Venera probes limited themselves to flybys of the planet to gather data using remote sensing techniques. Later, other vehicles were parachuted into Venus's atmosphere to directly measure its properties during descent, which lasted about an hour. The probes were battered by strong winds, reaching up to 320 kilometers per hour, or about 200 miles per hour. This is because compared to the solid planet, Venus's atmosphere rotates very quickly. As we mentioned before, the planet completes a full rotation on its axis in 243 days. But the higher regions of the atmosphere at the equator take only 4 days to circumnavigate the planet, with wind speeds varying from around 360 kilometers per hour or about 220 miles per hour in the upper atmosphere to just a light breeze at the surface. To withstand the intense heat and corrosive acids in the atmosphere, the Venera landers had to be heavily armored. They looked more like sturdy steam locomotives than spacecraft. The engineers who built them knew they would be parachuted into an environment with prohibitive conditions, including nightmarish atmospheric pressure. The first to successfully land on Venus was Venera 7 in 1970. Something went wrong during the descent, which was much faster than expected. The spacecraft hit the ground at the speed of a car in a severe accident, damaging the instruments. Fortunately, the lander was robust and didn't get destroyed. It only toppled over, but the side with the radio antennas ended up pointing away from Earth. Despite this, for 20 minutes, a faint radio signal managed to send information about the planet's surface. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You'll help us to make products of even higher quality. Venera 8, however, was the first probe in the entire series 1972 to 1984 to land successfully. Typically, after landing, each vehicle would last at most an hour before the heat and atmospheric conditions caused the instruments to stop functioning. The missions showed that Venus's thick clouds didn't reach the planet's surface, but visibility of the landscape was still limited. The landers spotted hills no more than 3 to 5 kilometers or about 2 to 3 miles away, while at their feet they saw black slabs of magmatic rock, scattered and cracked. The nature of the farther landscape remained mysterious. Studying Venus in the classic way by trying to light the environment with spotlights had strong limitations. Radars, however, could penetrate the clouds, forming the basis of subsequent exploration. After some experimental investigations, significant progress was made with 2 Venera missions, Venera 15 and Venera 16, both launched in 1983. These probes were equipped with wide coverage radar systems, with a spatial resolution of about 1 kilometer or 0.6 miles, and a height resolution of about 50 meters or 165 feet. The missions identified recognizable volcanic features and other decidedly unusual. Venus had shield volcanoes and numerous volcanic cones, structures we know well because they are also present on Earth. But there are others that don't exist on our planet, such as coronae, large circular structures that had previously been mistaken for meteorite craters filled with lava. Not exactly volcanoes as we understand them on Earth, but rather typical annular structures created by liquid lava escaping from an underlying caldera and forcing its way through cracks in the lithosphere. A similar process on Earth formed the volcanic islands of Hawaii. In areas where these coronae form, the crust undergoes concentric collapses that produce rings with diameters ranging from 100 to 1,000 kilometers, or about 62 to 621 miles. Over 500 coronae have been identified on Venus, many of them located on the highest plains, the regions most affected by crustal compression. The authors of the study propose examining the morphology of these coronae using ultra-high-resolution simulations and using them as indicators of recent outbursts of magmatic material from the mantle. Then there are the arachnoids, collapsed domes with radial cracks that resemble spider legs. Both these structures signal the underground presence of stationary hotspots, which generate bubbles of magma within the planet's crust. Venus doesn't have moving tectonic plates colliding with one another, so its volcanoes aren't aligned like those on Earth along the Pacific Ring of Fire. They're scattered pretty much everywhere. The breakthrough in studying Venus's surface came with an important mission, the first interplanetary mission by NASA after an 11-year hiatus. Launched from the Space Shuttle in 1989, the Magellan probe reached Venus in 1990 and orbited the planet for 4 years. Its name was a clear homage to Ferdinand Magellan, the explorer who first circumnavigated Earth. The probe's central body, the module, was ingeniously assembled in a low-cost operation using spare parts from previous missions, and it was equipped with radar to map Venus. To outdo the Venera missions, NASA boosted the radar resolution from 600 to 100 meters, about 200 to 328 feet, allowing Magellan to see geographical details roughly the size of a soccer field. The probe didn't orbit along Venus's equator. It traveled from north to south and then back up, flying over the poles and completing an orbit every 3 hours, while its orbital plane remained fixed in space as the planet rotated beneath. In doing so, the probe observed almost the entire planet, mapping one slice after another and creating a radar image that revealed the ups and downs of the terrain, that is, its geomorphology. Venus's glory was unveiled, and its secrets were finally in plain sight. Magellan revealed that almost 3/4 of Venus's surface is a volcanic landscape. There are almost 100 shield volcanoes similar to Hawaii's Mauna Loa, and hundreds of thousands of smaller, isolated volcanic cones like Mount Etna. In general, Venus's volcanoes cover larger areas, although they aren't taller than those on Earth. The tallest volcano, the Maxwell Montes Massive, reaches 11,000 meters, or 36,089 feet, comparable to the height of Mauna Loa measured from the ocean floor. The channels of solidified lava which flowed down the slopes of these volcanoes appear as sinuous lines of irregular, distorted rocks, similar to lava flows on Earth but much longer and broader. These differences are probably due to variations in the composition of the surface rocks. Those on Venus must be more ductile. About 10% of Venus's surface is covered in dust that has accumulated on the plains, blanketing everything. This dust comes from the erosion of the highlands, which in turn is driven by chemical reactions between the rocks and the atmosphere. Since there isn't much water on Venus, only a little in the atmosphere, the erosion isn't caused by water as it is on Earth. Instead, it's partly due to wind, which lifts the dust and wears away the remaining rocks, and partly due to meteorite impacts that shatter the surface rocks and spread fragments everywhere. Venus is as rich in volcanic craters as it is poor in meteorite craters. Only about 1,000 meteorite craters have been identified, many fewer than those on Mercury and the Moon, both of which lack an atmosphere, yet many more than those known on Earth. Terrestrial craters have largely vanished because they are eroded by atmospheric phenomena and because the movement of tectonic plates continually renews the surface. On Venus, there are atmospheric processes but no tectonic recycling. The reduced number of craters is partly due to the atmosphere protecting the surface from impacts, as meteors tend to disintegrate before reaching the ground. In fact, many craters appear in clusters, as if formed by fragments of a meteor that broke apart without being completely destroyed and fell together. However, the main reason for the scarcity of craters is that in terms of planetary age, the surface of Venus is as young as Earth's, despite lacking active tectonic plates. Perhaps in the past there were more craters, but they have since been covered by new volcanic material and now lie beneath the surface. By linking the number of craters to the frequency with which asteroids hit the planet today, astronomers have estimated that Venus's surface is about 500 million years old. This means 3 or 4 billion years or more of the planet's history remain hidden, a secret beneath its relatively fresh surface, a past wiped clean like a secret agent's changed identity. Has the renewal of the surface occurred gradually over the past 500 million years, or did it happen all at once about 500 million years ago? It's likely that today there are some active volcanoes on Venus, and in a couple of cases, volcanic ash emissions have been observed. The recent European space mission, Venus Express, identified hotspots on the flanks of some volcanoes, suggesting that beneath their surfaces there are pools of glowing lava, even though no true eruption has ever been observed. Venus is geologically active, but not very much. This suggests that the period of intense volcanic activity dates back a long time. The volcanic activity that renewed Venus's surface was a catastrophic event. What was the cause? Was the entire planet consumed by the fire of volcanoes unleashing all the pent-up rage inside? Or was the lava flow triggered by an external factor? For now, this phase in Venus's history remains a mystery. The renewal spurred by volcanic activity wasn't the only global catastrophe to hit the planet. Today, no trace of water remains on its surface. But according to astronomers, when Venus formed 4.6 billion years ago, and for a period thereafter, it likely wasn't very different from Earth. In fact, it's reasonable to think that at birth, all the terrestrial planets, Mercury, Venus, Earth, Mars, shared similar conditions. Essentially, all newborns look alike. As they matured, however, these planets became distinct individuals, both because small natural differences grew over time and because they were educated in different environments. If it's plausible to support that liquid water once graced Venus's surface, delivered by asteroids and comets, then the planet likely also had an atmosphere made up of nitrogen, water vapor, carbon dioxide, and methane produced by volcanic eruptions. The carbon dioxide and methane would have created a powerful greenhouse effect, further amplified by water vapor as the oceans evaporated due to Venus's proximity to the Sun. The greenhouse effect is a property of certain gases in a planet's atmosphere. On Earth, it's crucial because it keeps the surface at a relatively constant temperature conducive to sustaining life. It was Joseph Fourier, the French mathematician and physicist, who discovered the greenhouse effect of Earth's atmosphere in 1827. Earth receives sunlight and absorbs about 70% of it. The absorbed energy warms the ground, the atmosphere, and the oceans. The warm masses then radiate heat back into space as infrared radiation, which is largely absorbed by greenhouse gases and clouds in the atmosphere. Rather than dispersing into space, the infrared radiation rises the temperature in both layers of the atmosphere. In this way, the heat from the ground and oceans can't escape, and the surface and lower atmosphere keep getting warmer, much like a greenhouse, and that's where the analogy comes from. From the very beginning, the greenhouse effect on Venus was much more intense than on Earth. The planet heated up to the point where its oceans completely evaporated. This happened long before the volcanic resurfacing wiped out any traces of those oceans, rivers, or water-formed minerals. All the water vapor that ended up in the atmosphere only worsened the original greenhouse effect, pushing the temperatures even higher. The atmospheric composition changed, and other greenhouse gases formed, like clouds made of tiny sulfuric acid droplets. As a result, the temperature kept climbing and so on. This explanation was proposed in 1961 by Carl Sagan, an astronomer at Cornell University, to account for Venus's extremely high temperatures. Its runaway greenhouse effect had spiraled completely out of control. Today, the greenhouse effect completely dominates Venus's climate, driving its temperatures up to 500 degrees Celsius or 932 degrees Fahrenheit. On Earth, by comparison, it only brings the temperature up to about 33 degrees Celsius or 91 degrees Fahrenheit, which, while considerable for our climate, is beneficial and not catastrophic. However, the human-produced or anthropogenic greenhouse gases generated by industrial activities in livestock farming, carbon dioxide from burning fossil fuels, and methane from cattle are causing Earth's temperature to rise, threatening to disrupt this delicate balance. The Paris Agreement of 2015 outlined the necessary steps to keep our planet's overall temperature from increasing more than 1.5 to 2 degrees Celsius, or 2.7 to 3 degrees Fahrenheit, above pre-industrial levels by limiting these emissions. Of course, no such controls have ever been applied on Venus, and its natural greenhouse gas emissions have increased far more dramatically than what we're experiencing here. Today, the planet is a hellish landscape of extreme temperatures and bare, arid, and sterile rocks. A horror movie scenario that vividly demonstrates the catastrophic effects of climate change. For Earth, a 2-degree increase in global temperatures might seem like a minor issue, especially compared to the 500-degree surge that Venus once experienced. But even such a small increase could prove disastrous, not necessarily for the survival of our planet, but at the very least for the future of our species. In the end, Venus stands as both a fascinating enigma and a dire warning. As we peel back its thick, acidic clouds and uncover the secrets of its runaway greenhouse effect, we're reminded of just how delicate the balance is between a habitable world and a hostile inferno. Venus may have lost its oceans long ago, and with them any chance for life as we know it. Yet its story is crucial for us here on Earth. It shows us that even small changes in our own atmosphere, whether from nature or human activity, can have catastrophic long-term consequences.